Good afternoon all. Welcome back to the lecture session of the 5-day short-term course. Today's lecture session will be taken by Dr. Prashant Kumar Tiwari. Let me give a brief intro about the speaker. Dr. Prashant Kumar Tiwari has received his BTech in Electrical Engineering with honors from UPTU Lucknow, India. MTech Power System from National Institute of Technology, Hamirpur, and PhD from the Department of Electrical Engineering, National Institute of Technology, Hamirpur. Presently, he is working as an assistant professor in Electrical Engineering Department, Motilal Nehru National Institute of Technology, Allahabad. He has served as an assistant professor at National Institute of Technology, Silchar. Sir has published various research papers in various reputed international journals, national magazines, international conferences, and national conferences. He is a member of IEEE, IAI, ISCS, IT, and IAENG. He is a reviewer of various reputed journals such as IEEE Transactions on Power System, IET Generation, Transmission and Distribution, Electric Power Components and Systems, Renewable and Sustainable Energy Reviews, Energy Policy, Renewable Energy Focus, International Journal of Computers and Electrical Engineering, and various other such reputed journals. His research interests are in the area of facts, power sector deregulation, and renewable energy sources. I would request Sir to start his presentation. Sir, please.
Thank you. Thank you very much, Dr. Sally ma'am and other team members for inviting me to deliver this lecture in your workshop. And I would also like to welcome all the participants, those who are currently attending this session. Now, in this session, we will focus briefly on the role of electricity market in modern power systems. Since we are dealing with the electricity market nowadays, so it is our responsibility as a power engineer to take care about the whole system, and as a researcher, our responsibility is to just doing the research in such a manner that we can sustain our power system, our current power system that we are talking about. Under this discussion, we will go with the regulation versus deregulation, brief history of deregulation, technical challenges and focus areas for future sustainable grid, critical elements and associated driving tools, control and protection paradigm of the future, the scope of renewable energy integration and its impact on the electric grid. And we will consider an example which is in the similar line, which we will discuss. Now, first, I would like to discuss here about the regulation versus deregulation. If we will be talking about the regulation, characteristic and structure, then we can say the regulation means that the government has set down laws and rules that put limits on and define how a particular industry or company can operate. Now, we all are familiar that any country, there is some central body that deals with all the system, and here the regulation is just such kind of rules and regulations that is formed by the central authority, and that will be followed by top to bottom manner. So if you can say the regulation means it is a vertical integrated utility where it will be applicable. So under this particular scenario, if you'll be talking about, then the main problem with the regulated power market is our monopoly. As we know, before deregulation, our power system was working like this. One central authority is there, one entity is there. Government was the it is called the everything did by the government. Now, under that scenario, the first and major drawback is the monopoly. So monopoly is in the sense is that whatever the government will be setting from one side, that need to be followed up to the bottom. All right. So this is not good for a healthy system, as monopoly deals with several problems. So it is not good for any power system. Now, obligation to serve. The utility must provide service to all consumers in its service territory, not just those that would be profitable. Here, the point is this. The entity that is given the responsibility to serve a particular territory, that will serve under that territory only. It will not disturb the other territories. All right. So, and here the profit is missing. Whatever the way utility will be serving, in that way a customer has to accept everything. So it is also not good for the power system, and we're talking about the efficient and healthy power system. That is one of the drawbacks also. Now, the least cost operation. The utility must operate in a manner that minimize its overall revenue requirements. And the regulated rates, that utilities rates are set in accordance with the government regulatory rules and guidelines. As just now I told, the rates of electricity was decided by the government, and there is no scope for the consumers to opt their choices. All right. So that is another drawback of the regulated power market. Now, if you can see this diagram briefly explains the structure of a regulated power market, where we can see the major components of a power system: generation, transmission, distribution. All are under control by one company. And if you can see here, the end users can only collect the energy, and they can only pay the money for utilizing their energy. All right. So the energy money flow, if you can see, the money flow is unilateral here. Okay, only from left to right to left. And if you can see, the power flow is from top to bottom. And major thing is that information flow is only between the generation, transmission, distribution, large entities. It not with the end users or small consumers. All right. So this is the drawback, considered as a drawback for the regulated power market. You are not getting the freedom to choose your supplier. You are not getting freedom to use your appliances as per your wish and in economical manner. So in order to avoid this characteristic and structure of the regulated power market, the concept comes that is called the deregulation, or you can call it the restructuring of the power sector comes. Now, what happens under this new scenario? Here, the power industry, deregulated in the power industry, is a restructuring of the rules and economic incentives that are government setups to control and drive the electric power industry. Here we can see again the government setup, the rules and regulation, but here the whole structure had been unbundled. All right. Previously, it was bundled and it was called as the vertical integrated utility. And now it will be unbundled and it will be splitted into the three major parts like Genco, Transco, and Disco. And every entity will deal the particular their particular reason. Generators deals with all the generation related issues, transmission related issues, and this course deals with all distribution related issues. So now what happens here, the independent firms compete each other. What will be done here, if the generators will be dealing only generation, and all the competent generators are allowed to appear in the power market, then what happens? The competition will arise here. All right. So this is the first good thing regarding the deregulation or the deregulated power market, where independent firms compete each other in terms of prices and sell their electricity to customers through an independent entity, that is transmission line. So what happens here, n number of generators, G1, G2, G3, up to n number of generators can simultaneously enter into the market, and they can bid their prices and compete with each other. And most competent generators will be only allowed to just deal in the competitive electricity market. So here the competition is involved, and once the competition is involved, then obviously the quality will improve, the functioning will improve. All right. And another example is a kind of we can say the airlines restructuring, and our we can say the communication, like if you want to use Air India flight, you are free to choose flights. Air India, you are free to choose any airlines. So like this, in under this new scenario, customers are this is customer centric actually, and here the customers are getting opportunity to choose their providers, and they have to also participate in the electricity market. Now the energy market, in which the trading of energy takes place between buyers and sellers in form of bids, as I just now told. Gencos also submit additional information apart from the bid, energy bid. They also submit the additional information such as no load cost, ramp up and ramp down rates, startup and shutdown cost, minimum up and down time to the ISO. And I will discuss further what is the ISO. The market operation is to maintain system security and economical operation while considering all the network constraints. And here, obviously, the monopoly will be removed. Why monopoly will be removed? Each and every section is having its own, apart from the government setup rule, they have to set up their own rules, and they need to maintain the whole section, and for that the monopoly will be removed. Another term is the non-discriminatory access allowed for open access facilities. So non-discriminatory access, that was not, this facility was absent in case of regulated electricity market, and there is no transparency in that case. Here we can see the transparency will be also there in deregulated electricity market. Whatever will be done by the system operator, that will be transparent for generation participants as well as demand participants. So all the market participants will be knowing what will be happening in the future, and accordingly they will decide their bidding approaches. Here, one thing I would also like to emphasize, that one thing called the market power. If we are discussing about the electricity market, then the thing that is important is called the market power. So what is the market power? In market power, previously what happens in a particular area, the generator who provides means larger generation capacities, they are just trying to put down the small generators. All right, like this is called a market power. It means if customer want to take the power from small generators, then larger generators can influence that delay. Okay, so this kind of things are called the market power, and that will also absent in case of deregulated or restructured system. Now here the advantage of deregulation. Once the competition will be involved, I told you, so the cost saving and cost effective pricing will be there. All right. Now lower prices resulting from competition, lower prices resulting from increased electricity trade, and saving in investment costs, etc. So many things are there that will be dealing the cost saving and pricing also. Okay. Now here the competitive electricity, it is also termed as the competitive electricity market. And in the competitive electricity market, the main goal is economic benefit. Everybody is running towards getting the profit, okay, either from the generation side or from the distribution side, okay, and from other participants, okay. All are just running towards getting the profit. So here the economy will be tilt if you will compare the same thing with the regulated power market. Now the effective capacity planning, the capacity planning we can do effectively when we will be knowing everything is transparent before you, that these are the existing things and these things need to be added in the future. Okay, so it will affect the capacity planning itself. Now development of new and better service and more customer choices. It has been already discussed. Now motivation for innovation. This is another major thing, that once the competition will be involved somewhere, then as a participants, you will try from your side to do best. Okay, and for doing the best, you will try to adapt, or you will try to innovate something so that you will be able to put yourself at the top. Okay, so innovation will be involved under this era. If you can see this structure, and if you can compare how this structure is different than the previous structure that we have just now seen, here you can see the generation, transmission, distribution, and load-in customers. If you can see, apart from these three entities, two additional entities are involved here. This is, you can see at the bottom side, one is called the ISO and another is entity is the retailer. All right. So what is the ISO here? You can see in the previous case, all the dealing was between generation, transmission, and distribution. Okay, and it will be from the top to bottom. Now here, if you can see, the energy flow, information flow, and money flow has been represented here. So the ISO is the supreme entity of the deregulated power market, and it termed as independent system operator. It is called the independent system operator. Why it is called the independent system operator? Because ISO is having its apart from the central rule, ISO is having its own rules and regulation, and all the channel will be maintained by the independent system operator. All the reliability issues will be taken care by the independent system operator. All what you can say, all the rules and regulations, overloading, congestion, all these things need to be taken care by the ISO. So ISO is the supreme authority in this deregulated power market. And if you can see here, the information can be flowed between generation, transmission, and distribution. Okay, but if you can see here, the customer can directly deal with the generators here. At the top dotted lines, if you can see from right to left, you can see the customers are free to choose their providers. This is the major things in the deregulated power market. And another thing you can see, the customers either can directly contact to the generators, or customers can enter in the market through the retailers and ISO. Okay, so who are the retailers? Retailers, all the electrical distribution systems are, in terms of market, will be dealt by the retailers. Okay, retailers will be collecting the cost of the electricity, and retailers will be passing this cost towards generation side. Okay, and it will be also coordinating with the ISO transmission and distribution. All right, so if you can see this structure is more flexible than the previous structure. Previous structure was the rigid structure, where the customers are, that was not the customer centric. Here you can see it is a customer centric also. Brief history about deregulation. During the 19th decade, many electric utilities and power companies worldwide have been forced to change their way of operation and business and move fully or partially towards open competitive market. So this deregulation starts at the early 90s. Okay, and these changes could be specifically observed in UK, US, Sweden, Norway, Finland, and some countries of South America. If you can see, in 1989, UK was the first country to realize the privatization of vertical integrated electricity. As I just now told, the vertical integrated electricity was the old era, and now you can see the new era is of horizontal based system. Previous it was the vertical based system, now it has been horizontal based system. In year 1996, Nord Pool was established as the first international power exchanger in the world. So what is the power exchanger here? The power exchanger deals with all power exchanger is assigned by the ISO. Power exchanger takes care of all the market activities in the system, like bids matching, okay, collecting the bids, and all these things will be dealt by the power exchanger. Okay, so power exchanger, you can say, one of the hands of independent system operator. So you can see the first international power exchanger was established by the Nord Pool in 1996. If you're talking about our country, India, so India started its reforms towards the restructuring power system in mid of 1990s. Okay, and Odisha was the first state where the restructuring was started. Now, what happens after starting the restructuring? Government feels that without a particular regulation, without specific rules and regulations frame, it is very difficult to run a competitive electricity structure. So what has been done by the government? Once Electricity Act 2003 was came into force, okay, so Electricity Act 2003 was found for creating competitiveness, rationalizing tariffs, ensuring continuity of supply of electricity, protect consumer interest, and lowering of cross subsidization level. All right, but what happens? Further governments feel that there should be some changes in the already existing Electricity Act. So the existing Electricity Act 2003 was further amended in 2007 and 2018. Okay, and various norms have been considered under these two amendments. Now, recently, if you can see, the draft electricity amendment bill is now going on by the current government, and it has been circulated for the comment. If you can see, in order to address some recurring issues and to promote further commercial incentives for private players to enter the market in the generation, distribution, and transmission of electricity with some policy modifications, the draft Electricity Amendment Bill 2020 had been circulated by the Ministry of Power on 17th April of this year. All right. Now we can see here what are the key proposed amendments in the recently ongoing bill. First is the direct benefit transfer. It may be DBT. It is, in short, you can call it the DBT. So government has emphasized the DBT. It may be beneficial for both the state governments as well as distribution companies. Next is National Renewable Energy Policy. So it is proposed to have a separate policy for the development and promotion of generation of electricity from renewable energy sources specifically. All right. So this amendment particular point will be taken care by the government in this new bill. Second thing is the policy in the bill prescribes a minimum percentage of purchase of electricity from renewable sources of production, and it also seeks to give special attention to hydropower. So hydropower has been emphasized under this amendment. All right. Now the sustainability. The amendment prescribes a period of 60 days to adopt the determined tariff. Failing to do so would result in the tariff being deemed to be accepted. If 60 days will be passed, then tariff will be automatically accepted. Now the payment security will be there. The bill also proposes to empower load dispatch centers to oversee the establishment of adequate payment security mechanism before dispatch of electricity as per contract. So all load dispatch centers are empowered with this security option, payment security option. So it is also under consideration. Now, ease of doing business, it's proposed to establish an electricity contract enforcement authority. Okay, one authority will be established, that is called ECEA, which will enforce performance of contract related to purchase or sale or transmission of power between a generating company, transmission licensee, or distribution licensee. So what has been done here, one authority is dedicated for the current business model. Okay, so all these things are under discussion, and let's see what will happen when this bill will be confirmed from the parliament. Now the major point is why renewable power. You all are familiar with this particular fact, because nowadays we can see the more emphasis is giving on the renewable generations. So major things, actually I have sorted these two things. First is to fulfill the gap between generation and load demand. First thing is, in order to fill the gap, renewable energy is required. And second thing, by considering the environmental, social, independent, and financial beneficial properties. Okay, so this is beneficial, but renewable energy is also having many problems. Okay, and the research is still going on the various aspects of the renewable energy system. Here, I would like to mention the major trends driving power system evolution. if we are discussing about the power system evolution, then these are the things that will correlate this particular evolution. First is the renewable energy cost reduction. If you are discussing about the renewable energy, so obviously when the conventional energy is being replaced by the renewable energy sources, then as compared to the conventional fossil fuel system, the renewable energy based system is cost effective. So once we are inserting the renewable energy into the system, then the dynamics of the system will be changed. So here we are discussing about the cost reduction. So cost will be disturbed. So once the cost will be changed, so I told you in the competitive electricity market, cost is the major factor that we deal. Okay, so that's why the renewable energy integration is being important in the competitive electricity market, and we can see how the researchers have been exhaustively done the research based on this particular point. Now, the innovations in data intelligence and system optimization. Okay, so if we are discussing a power system, so power system is not just like producing the electricity and delivered to the load end by the transmission channel. It is having another responsibilities like data innovations in data intelligence should be there, and there will be some specific and robust system optimization tools, okay, that need to be developed from the power system researchers, okay, power system what you can say, the operators, okay. So innovations in data intelligence and system optimization, we can see these are the terms who are affecting the current power system evolution. Now, energy security, reliability, and resilience goals. So if we can discuss the energy security, reliability, and resilience, customer engagement. Here we can see from the previous era. So what will be done here? Once the customer will be engaged into the activities involved in the power system, then what happens? You cannot ignore them. You have to consider. You have to listen the customer voice also by considering all the major constraints or system constraints. All right. Now the increased interaction with other sectors. So now we can see the power system will be interacting with the other sectors, and in sorry, yeah. So power system will be interacting with the other sectors, and other sectors are not free from the impact, or you can say the development of the power system. Now, local and global environmental concerns over air emissions, these are the major things that we have to take care once we are talking about the modern power system. Okay, so when you are doing something from your side in terms of research and development in power system or power market area or renewable energy area, then we need to consider this environmental facts. We have to take care about this. Now, increasingly diverse participation in power markets. We can see power market is a diverse market where n number of different entities can be entered together and can participate in the system, and they can show their influence in the system, and for doing so, the system is most robust as compared to the previous old systems. All right. So the revenue and investment challenges, as I told, the revenue is the main concern, and the investment challenges we need to address for getting the modern power system dreams. Now, here I would like to mention the specific technical challenges and focus areas for future sustainable grid. First is the energy independence and affordability. Our system should have energy independence, and it will have affordable. Now, what happens? The demand will be changing in rapid manner, and we are having n number of tools to predict our demand. Okay, so research is still going on towards because in the competitive electricity market, if you are talking about, then we have to predict our demand, we have to predict our generations patterns, and then we have to create a day-ahead market. And in that day-ahead market is every participants will be participating, and the real-time market will be the reflection of that day-ahead market. All right. So the affordability is the major concern here. Your power system should be affordable once the dynamic change in the load can be borne by your power system. Now, the energy reliability, security, and efficiency are the major concerns, major challenges. Now, economic development and job security in this particular area is also a major challenge. All right. So every system operator will have the responsibility to recruit the power system engineers who are highly skilled and who are highly trained. That will just consider their job efficiency, and by doing so, their job security will be there. So these are the major concerns. Maintaining this job security is also major concerns here. Now, the environmental concerns and impact of climate change I have already discussed. Aging infrastructure, technology change, and workforce needs. Now, here I would like to emphasize on the workforce needs. Currently, our structure in such a manner that we are doing BTech, we are doing MTech. Okay, in BTech, you are just going through all the related subjects. Now, in MTech, we are going just with some specialization, and in PhD, we are doing some research work that may be the outcome towards this particular area. So the meaning is that the workforce need to be developed in such a manner. A trained workforce is required. Okay. Now, if you are only with the MTech, then you need to be trained with that power system related things. Only when you will be you can deal the system effectively. All right. So the training kind of thing is required at the routine intervals for the power system engineers. Okay. Now, if you can see, the power generation and transmission capacity must be sufficient to meet peak demand. Okay. So power system, I just affordability I have discussed. It is related to that. Now, the power system must have adequate flexibility to address variability and uncertainty in various system components. Okay, so the flexibility must be there. Okay, flexibility, without flexibility you cannot consider any system as efficient. Okay, the power system must be able to maintain desired frequency and voltage. We all know these facts. Now, what are the solution options? And further, I will discuss what are the concerned area where we can emphasize our research. So the solution options are the advancements in renewable resource technologies. If you can see, we need to focus on this particular point. Now, if the renewable energy sources are available, then point is that where we have to deploy these renewable energy resources. Since these are based on the geographical kind of thing, then we are bound sometimes to just put renewable energy sources at the particular point. Now, if we are going for the distributed resources, then we can add them at many as per your own wish. But point is that where we need to introduce with the system, the point of interaction, that is one of the major things. So research has been exhaustively done in this area. Another important thing is when you are interacting with the renewable energy, either in the grid connected mode or in the islanded mode. So when you are going for the grid connected mode, then you need some inverters, converters to interact the renewable energy with the system, and those converters are based on the recent developed power electronics based equipments. All right, so the power electronics technology need to be addressed here. Okay, so the research is still going on in this area, so we need to emphasize on this particular point. Now, next is effort towards energy efficiency. Obviously, the energy efficiency is the major part when we are discussing about the competitiveness and efficiency of the system. Okay, so we can see the several examples for the energy efficiency in our daily life. So we need to take care these things in the context of competitive electricity market. Now, the demand resource management. This is directly related to and it can highly impact on the electricity market. So, demand resource management, by using this particular management, will be able to change. We will be able to reflect the changes in the competitive electricity market, and it is a bilateral kind of thing. The demand resource management, from which reference you want to do the demand resource management. So the competitive electricity market, either you can get the signals from direct signal, price signal from the competitive electricity market, and then you can do the demand resource management at the demand side. That is one option. And another option is the direct interaction of this diverse sources in the competitive electricity market, and for those sources you can do the demand resource management. Next is the electricity market solutions. Various problems are there in the electricity market. When we are talking about the perfect electricity market, it is a dream, and still research is going on the various problems in the electricity market. One of the major problems is congestion. You can see the congestion management. It has been exhaustively reported in the past, and nowadays also, because we are having limited resources, limited channels for transmitting the power, and we have to take care about the ATC of the system. We have to take care about the physical constraints of the transmission lines before transmitting the power from generating end to the load end. So this kind of electricity market problems, solutions, options are there that we can deal with. Now, the improved asset utilization. This is the major thing, because everybody wants to use the new thing with the improved reliability, improved efficiency, improved innovative kind of things. But whatever the things existing, that we need to utilize, reutilize. So for that, the whatever the asset we have to reutilize, we have to utilize effectively for our system. Now, the electric transportation flexibility should be there, and the energy storage technologies. The research is also going on this particular topics nowadays. Now, there are some research opportunities, trends in transmission era. First, if I will discuss the assessment of advances in basic energy sciences to utilize selected technologies. So, the impact of use of those technologies in a power engineering context, whatever the basic energy sciences and the concept was developed, that concept need to be modernized, and with those modernized kind of thing, we need to use the new concept in our power engineering context. All right. So the reduction of dependence on fossil fuels, obviously, if we are going for the alternative resources of energy, then we are going for reduction of the fossil fuel based system. The implementation of digital computational tools are also important for the next generation power system. So when we have to create a robust system, then we have to develop a smart tool also. All right. So these are the major things, or some research opportunity, some area, broad area where we can look for. Here, we can see the critical elements and associated driving tools. Here, I have presented 4 major elements. You can see the changing generation supply mix. If we are dealing with this particular thing, then we need the evolution on transmission, distribution, additions and changes, energy storage, enhanced control, communications also, handling increased uncertainty. If you can see here the uncertainty, so our power system is completely uncertain, and if we are dealing with because in the modern era we have to do everything beforehand, before execution. We have to decide the outcomes before execution. So the all uncertainty need to be taken care here. Okay, and for this needed evaluation, there are some driving tools that we can see here. For this, the renewable resources should be addressed, retirement of aging conventional plants, questions regarding other alternative sources of energy. Now, demand transformation, if you are discussing this particular point, then we need to think about the expanding digital economy, power quality and reliability needs, demand flexibility, electric vehicles, etc. And the related driving tools we can see here, the changing customer needs, green awareness and demands, need for higher reliability and efficiency. Next is the complexity of the electric grid. Now, if we are discussing about the competitive electricity market, then the competitive electricity market is a very complex market. All right. And under this complex scenario, we need to resolve the issues as early as possible. So for that, the complexity need to be addressed here. So what are the impacts of the market? Tighter operating limits, greater reliance on communication and control, need for advanced analytical tools, etc. We have to address for addressing the complexity of the electric grid. Now, infrastructure vulnerability, if we are discussing this particular point, then we have to think about the reduced footprint of disruptions, reliability of communication and control, reduced duration of disruption, guard against malicious attacks. So these are the elements, these are the areas that in which the research is going on, and then we can focus on these particular areas also. Now, the control and protection paradigm of the future. If you are discussing about the future grid, then we need to address the control and protection things. The control and protection have a strict requirement for latency of measurement and control signals. And it needed a smart grid with new control and protection scheme that is already going on. The system is just moving faster to achieve the smartness in terms of a smart grid. And the design, installation, operation, and maintenance of such control protection schemes that we need to take care. And the need of hierarchical coordinated control and protection is also required when we are done. So all these 4 points are related to the control and protection, where we can emphasize our research. Here, the renewable energy integration and its impact on the electricity grid. So here I would like to discuss a few points. Those are important for the future grid. All right. So first point that I would like to discuss, that the direct and indirect coupling of renewable energy resources with flexible load. What is our goal here? What is from the demand side, what we can do? From the transmission side, we are having limited availability, limited resources from which we can generate the power, and we have to deliver the power to the load end. Now, if we are talking about the efficiency, then we need to talk in terms of load management also. Okay, so here I would like to emphasize direct and indirect coupling of renewable energy resources with the flexible loads. Some loads are flexible in nature. So what we've done here, we can directly couple the renewable energy sources with these flexible loads, or indirect coupling is also there. So this task focuses on utilizing demand side flexibility as a hedge against supply uncertainty caused by the inherent intermittency of renewable energy resources. So why it is a hedge against supply uncertainty? That if renewable energy, we all know the renewable energy is highly uncertain. So once the dynamics of renewable energy is being changed, accordingly, if we can change our flexible loads is following the change of the renewable energy system. So if we are changing those loads as per the change in the our renewable energy sources characteristic, then we can see the intermittency of the renewable energy sources can be addressed here. So we can take this particular area also. Now here, time flexible demand side resources could adapt their energy consumption according to the fluctuation of renewable power supply in order to buffer its variability and enable large scale integration of renewable energy without significant impact on grid operation. So if I can say for this particular topic that research need to be done, like how we can change, how we can plan our flexible load, how we can control that our intermittency can be met by changing the flexible loads itself. So what will be the expected outcome for this particular area? To develop optimal strategies for direct coupling of flexible load with wind resources in the context of a competitive electricity market. So what we can do, we can develop the optimal strategies for this, how we can directly couple the flexible load with the renewable energy sources so that we can reduce their intermittency. All right. So one of the outcome maybe the research area under this particular thing. Now, simulation-based comparison of direct coupling of wind and flexible load versus centralized market approach based on price signals and load response to be done. What is the meaning of this second term? Here we are talking about the comparison of direct coupling of wind and the change in the flexible load due to after taking the signals from the market, price signals from the market. So it is a centralized approach. Okay, so we can do in both the manners. We can wait for the price signal from the electricity market, and based on that we can change our behavior as a load. Okay, then this will be the another area of research. Now another is to design of a smart charging algorithm for PHEVs batteries that optimizes the use of coupled wind power and spot market energy procurement. Okay, so now we can introduce a smart charging algorithm for PHEV. Research is still going on this particular topic. How we can develop a smart charging algorithm for PHEV so that we can use the same in the competitive electricity market. Now, second is mitigating renewables intermittency through non-disruptive distributed load control. If you can see the non-disruptive distributed load control, so there are some loads that those are non-disruptive in nature, and how we can mitigate the renewable intermittency by using those non-disruptive distribution load, by controlling those loads. Okay, so it is simpler for the utility of or aggregator to interact with a small number of large customers than a large number of small customers. So it is always better to have large number of small customers for any system. Okay, when we are discussing about the competitive electricity market, it is not only for the competitive electricity market. It is for all kind of system where large number of small customers, large number of small customers are not preferred. You can prefer the small number of large customers. Okay, why? Here you can reduce the complexity of the system here. Okay, the complexity will be reduced drastically if you can convert the small customers by using the aggregators. All right, that's why in nowadays our whatever you will think, whatever if you are thinking about the small loads regarding PHEVs, all will have an aggregator, and that aggregator will be taking part on behalf of all small utilities, all smart loads to the electricity market. Now, benefits for using aggregation for small residential loads, if you are talking about the distribution system, so provide more reliable responses than a small number of large loads. Employ simple local controls. Local controls are also exhibits when we are talking about this aggregation-based system. Easy to model for state estimation and control purpose. So many benefits are there for aggregating the small customers with the aggregators. All right. So whatever the expected outcome is there, I have mentioned here. We can do the research in this area also, where we can see, and already research has been done in this particular area, and by using the aggregators, you can see many papers are available already. But we need to emphasize on their efficient operation, their efficient participation, and whatever the needs from the competitive electricity market, that is coming from the efficient in actioning, then we can deny to take their participation. Now, planning and market design for using deferrable loads. Now we can plan for a good market design using deferrable loads. Now, deferrable demand separates the purchase of electric energy from the delivery of energy services. And with these capabilities, customers are not inconvenienced. All right. So the type of deferrable demands to be investigated, like plug-in electric vehicles, by managing their charging and discharging profile, as just now I told you. In particular, intelligent PV charging discharging can provide ramping services to mitigate wind variability. It's expected that aggregating PV and thermal storage will provide an effective way to increase the penetration of renewable energy by mitigating the inherent variability of these sources and reduce a way to reduce criteria emissions and improve urban air quality, low total system costs, etc. Now, what is the expected outcome here? If we can see, we have to emphasize on the new methods for incorporating the deferrable demand. Evaluation and recommendations on how to improve current market designs and environmental quality that we need to take care here. Now, next is the assessment of whether or under what condition it makes sense to aggregate deferrable demand to provide system services. As just now I was talking about that whether they are preferable for the competitive power market scenario or not. The time is correct or not. At what time they have to enter, at what time they have to remove, that need to be decided. All right, so we can do a good research work on this particular area. Next is the probabilistic simulation of power system with integrated renewable demand response and storage resources. So why the probabilistic simulation? A computationally efficient probabilistic simulation tool needs to be developed. The quantification of the economic, environmental, and reliability impacts in the simulation approach need to be carried out by varying levels of wind, solar, and demand response penetrations. All right. So various probabilistic simulation tools need to be developed. Currently, if you will see, the many simulation tools are already existing in our market. You can go with that, and we need to incorporate storage resources with renewable, okay, and with the conventional, because we cannot separate the conventional sources also. We cannot take the complete power from the renewable and DER sources. So we need to develop the probabilistic simulation tools which deals with the renewable energy, power market, and storage resources issues. All right. So what we can do here, the stochastic simulation tools may be developed to incorporate RES, DRs, distributed resources, and storage and their impacts on electricity market. This is very important. So whatever you can do, you can check the impacts of those on electricity markets. What is the impact of all these things on the electricity market? That is very important. Now I will skip this. Now, the computational challenges under highly uncertain condition. When we are talking about the efficient computational tools for the future power system, then there are various kind of challenges are there, okay, that we need to address, that we need to face when we are going to develop an efficient computational tools. Okay, so first is the decision-making framework for the future grid. So decision-making framework is very important, either from the manual, from the human side. Okay, not only here, everywhere. When in your daily life also, when you are planning for something, okay, then your decision-making framework is very, very important. All right. So what will be done? What will not be done? This will be happen. Okay, this will not be happen. That you have to decide beforehand, before execution. That is called the good planning. All right. That is called the very good planning. So, am I audible?
Yes, sir. You are audible.
Thank you, ma'am. Yeah. So not only here in competitive electricity market, in our daily life also, we have to plan ourselves better so that we can achieve the planned things in systematic manner. So the decision-making framework, this task is developing a broad decision-making framework for the future grid. It ensures that the goals of the future grid can be met. It addresses decision complexities also. It identifies the gaps and technological needs for the industry transition. Now the second is computational issues. After decision-making framework, what you do, next step is to develop to resolve the computational issues of optimization, because this is one of the major things of planning. All right. So this task is developing improved computational methods for long-term resource planning under uncertainty. Whatever a good planning should have various things that need to be covered under good computational tool. So the various kind of uncertainty need to be addressed when we are discussing about the renewable energy and distributed energy resources in competitive electricity market. So these are, their interaction is itself challenging things, and apart from this, the competitive electricity market and its establishment is good establishment is also a major challenge. So here we are introducing two kind of challenges together. One is the economic challenge along with our demand fulfillment challenge. All right. So to develop, implement, and test a method to reduce the number of scenarios considered in stochastic programming, to solve multiple variations of a bi-level optimization problem with uncertainty. If you will see nowadays, the competitive electricity market, renewable energy integration specifically, then you will see the bidding. Many papers you can see, many researchers you can see based on the strategic bidding. Okay, so this may be another area for which we can develop a very efficient tool to address this particular bidding strategies. All right. So when you are dealing with the stochastic bidding strategy by using the stochastic programming, then you need to emphasize on the bi-level optimization problem and various kind of uncertainty also. Next is hierarchical probabilistic coordination and optimization of distributed energy resources and smart appliances. This task is developing a three-level hierarchical stochastic optimization methodology in real time around the physical separation of power system into feeder, substation, and power grid. Now, what will happen? The three-level stochastic optimization methodology need to be developed here, which will take care from left to right, and we can say that from the global era to the local era, from the generators up to the load end users. All right. It addresses technology aspects and quantifies expected benefits. Next is the real-time PMU-based tools for monitoring operational reliability. It is developing a real-time PMU-based tools for helping operators with operational reliability issues. It includes system loadability condition monitoring, transient stability analysis, real-time line model, and equivalent parameter updating. So real-time PMU-based tools for monitoring operational reliability. These things are also important nowadays, and you can see the use of PMU in our system frequently. Okay, so by using these particular things, we can develop a very good computational tool. Okay, so point is that when we are moving towards developing an efficient tool, then we need to take care of these 4 points. Okay, now resilient cyber physical system, and obviously it is required for if dreaming a perfect future power system. Now I will take an example. What kind of example here? The concerned example is the profit maximization of wind integrated competitive power market considering economic risk. Here we have considered economy as a risk factor, and what has been done here, and modified IEEE 30 bus system is taken, okay, and here the risk has been accessed by using conditional value at risk parameter, one of the parameters for getting the degree of risk. Okay, it is a risk assessment parameter. So here what we have considered, that risk in terms of economy. So if there is some loss we are getting, then we are considering here as economic loss. Okay, so a bi-level optimization problem, it includes lower level as market clearance, cost minimization, CVR maximization, and upper level consists of profit maximization of each GENCOs and DISCOs. A system has been taken where a bi-level optimization problem has been developed. So level 1 deals with the market clearance, cost minimization, CVR maximization, and another level deals with the profit maximization of the market participants, for which the two different objectives were taken, and these objectives are just analyzed, and final we have found the final point based on the various contingencies, okay, in the system, and we have collected various scenarios, okay, and system decides which particular scenario is good for the system or not. Here this is the lower level objective. Here you can see in the upper level problem consists of profit maximization, as I told you. Here we can see the two equations here. Here the first equation is for day ahead, and the second equation is for real-time markets. And the expected profit of the GENCOs in forward market is given by the first term as the revenues obtained by the GENCO in the forward market and balancing market respectively. Okay. Now the second term gives the net generation cost, fixed cost plus variable of the GENCOs, and the third term gives the revenue obtained by the wind power production. So if we deals with the two cases here, case A is the profit maximized by applying appropriate strategies, and risk level of GENCOs has been checked, and in case B, the system profit is maximized, generation cost is minimized by optimal placement of wind generators, and risk at each node bus is checked. Here what we have got, we have calculated the profit based on the various bidding strategies, okay, and if we can see here for the GENCOs, the various kind of, you can see in the column discriminative, last accepted offer, first rejected offer, last accepted bid, FRB, first price, second price, like this. So all these are the bidding strategies, okay, all these are the market clearing approaches, okay. So here we can see under this particular problem, the first rejected offer based approach is beneficial for the GENCO point of view, as well as if you are discussing about the buyer's profit from the demand side, so the discriminative bidding is most appropriate for the DISCO point of view. So here if we are talking about the discriminative bidding, so it is nothing but it is called as pay as bid approach, okay. So pay as bid approach is whatever the bid has been given by the participants, in the similar manner it will be accepted. So it is called the pay as bid approach. So pay as bid approach is good for the DISCO point of view, because if you can see the distribution point of view, then the customers need to be, means their willingness to pay is judged by the system operator, okay. So if you are a customer, so how much you can pay for how much quantity, that is important. So how much money in your pocket, that is important, okay. If you cannot bear a particular amount, then you cannot participate in that system. So here, if you can take the risk assessment in day-ahead market, so the CVR has been calculated. You can see here the blue lines representing the risk level before wind generator placement, and red one shows the risk level after WG placement. So here, what we are calculating here, we are calculating the value of conditional value at risk, and once the value of conditional value at risk is moving towards positive, so what we have seen, if the CVR value is moving towards most negative towards positive, then our profit gets maximized. All right. So here, what we have tried to show the values of CVR for different risk levels. This is for the real-time market. The similar kind of thing is repeated. Now here we can see the generation cost in day-ahead market. We can see the changes before and after WG placement. And one thing I would like to mention here, that we have kept the location of wind placement at the place where the highest risky bus we have identified. Which bus is the highest risk, economical risk? Okay, that has been identified, and wind has been placed on that, and its variability will be taken care, and then we can see the results, and we can see this changes in the CVR values. Okay, so in this work, it can be observed that the generation cost is minimized, profit is maximized by optimally placing the wind generators at the most risky bus, as just now told you, in day-ahead market and real-time market, by assessing the value of CVR. The profit of GenCos and DISCOs are maximized by choosing appropriate bidding strategies such as discriminative and uniform pricing approach, like FRO, FRB, etc. It is observed that maximum profit can be achieved if FRO bidding strategy applied. It has been already discussed previously. The further risk can be minimized by allocating wind generators at the most risky bus under different contingencies. So here we are talking about the economical risk. I have emphasized this particular point at the beginning. Here we are not talking about its variable nature. Okay, once you will consider the wind variability, then it is one kind of risk. Okay, so that we are not considering. Means here we are considering the economical risk. Okay, where we are losing the profit, where we are getting the profit. This kind of thing we need to access, and we have to take the action against that. Now, the overall concluding remarks is that renewable energy sources grid integration in new era has many challenges and also creates opportunities for information technologies into the future electricity infrastructure in order to mitigate these challenges. So if you are talking currently about the smart grid and all this, then we need to emphasize on the IT-based system and infrastructure. Now, the traditional approach of mitigating supply and demand uncertainty through procurement of reserves from conventional generation resources is not sustainable and also uneconomical. So, massive penetration of renewable resources opens the door of sustainability and economy. Okay, so renewable energy sources, I told you at the beginning itself that they are less costly compared to the fossil fuel-based system, but we have many challenges to interact them with the system. Okay, so when we can emphasize on those challenges, we can address those challenges, we can come up with some good ideas, then it may be helpful for the future power system, and it may be one of the contributions from our side. Now, the cheap storage technology is the only viable alternative to mitigate the intermittency of renewable sources. At the planning level, computational challenges need to be addressed, like new optimization tools and simulation models are required to address supply uncertainty demand side flexibility, and intelligent periphery in competitive generations and transmission expansion decisions, along with economic and environmental benefits of future grid. Okay, so if we are dreaming a good system, good, perfect, competitive system in the future, good power system, then we have to come with some effort, some ideas which can address the many needed things of the future grid, and we can work. These are the references. And thank you very much and for your presence and listening my lecture from 1.5 hour patiently. Okay, so thank you all for this. Now over to us, Dr. Sahali ma'am or team members.
Thank you so much, sir. It was a
Thank you,
really
ma'am.
very informative session, and the participants have enjoyed a lot because we have got several feedback in the YouTube link that it was an informative session and it was a very nice session from the participants. So thank you for this nice presentation. With this, we have come to the end of this today's session. So Dr. Excuse me. So Dr. Prashant Kumar Tiwari sir has explained, had an analytical discussion on the role of electrical markets in modern power systems. Hope all the participants had enjoyed a lot from this wonderful presentation. Thank you all. Thank you, sir.
Thank you, ma'am. Thank you very much.
Thank you.
Thank you all. Should I leave, ma'am?
So we'll resume tomorrow's session at 9:30 a.m. Thank you all.